Hi everyone, I'll be speaking about database systems. I'm a student at Sabanj University. I'm majoring in computer science and engineering. So the topics being covered in the presentation include schema refinement, normal forms, functional dependencies, minimal cover, transaction scheduling, database general knowledge, and relational algebra. In the first question, we can see that it's asked that is A goes to C implied by F. And before we really get into this, there are three important properties that must be understood fully. And by looking at the property of transitivity, we can see that if x goes to y and y goes to c, then x goes to z. Is a goes to c implied by f? So the solution to this is yes. And the explanation is through transitivity. From f, we can see that a goes to b and b goes to c, so without doubt, it will go to c. Another question is find a key with respect to R. And before we dig into this, we must understand what is meant by a key. So we basically need to see all the elements that are reachable from that particular attribute. So in this case, we can see that if A goes to B and B goes to C and AB goes to D, through the properties previously mentioned, we can therefore say that A is a key and the closure of A is A, B, C, D. Another question is what is the attribute closure of A with respect to F? We must understand really what is meant by attribute closure. An attribute closure is basically defined as the attributes that can be reached by a particular attribute. It has three properties that I also mentioned earlier. And from F, we basically know that A goes to B and B goes to C. And we also know that AB goes to D. And therefore, the attribute closure of A, as mentioned earlier, also is A, B, C, D. Another question is AB a key for R? And this is similar to the previous questions, and the way to solve such type of questions really depends on whether we understand attribute closure. And we can see from F that if A goes to B and B goes to C, the closure of AB will definitely be ABC. Automatically, if there's an attribute closure, it includes the attributes that are being closed. So in this case, if we're looking at the attribute closure of AB, AB will definitely be included into the attribute closure. And because the closure contains all the elements in R, we can say that AB is a superkey. To understand what is minimal cover, we must understand a few important pointers regarding to really understanding what minimal cover really is. So in order to solve this question, there are a few steps that need to be followed. The first step is to break down those elements on the right hand side that have more than one attribute. In our case, the very first functional dependency AC goes to BD is violating this step, so we must deal with this first. So we can divide AC goes to BD by saying AC goes to B and AC goes to D. The rest of the functional dependencies will remain the same. Now the second step is basically to remove all redundancies, and we can remove AC goes to B because we simply know that A goes to B and B goes to C. We can also remove A goes to C because we know that A goes to B and B goes to C, so it's kind of given that A goes to C through transitivity. And all these extra redundancies must be removed. Finally, our minimal cover is AC goes to D, A goes to B, and B goes to C. Feel free to stop the video whenever to go over the concepts again. Now moving on to our second section of the presentation that deals with true and false. We're given a question on strict two-phase locking and whether it generates a recoverable schedule. The answer to this is true, and it's mostly based on the facts of really understanding what a two-phase locking schedule does. And because of the system of locks, strict two-phase locking generates a recoverable schedule. Another question is whether the projection operator in relational algebra can change the schema of the input relation. And this also again is based on the fact that projection operator in relational algebra does definitely change the schema of input relation, and this is because it basically deletes all the unwanted columns from the relation. So this is true. Weak entities cannot exist by themselves without a parent entity. This is also true, reason being that a weak entity is defined uniquely by considering the primary key of another owner or a parent entity. And if a parent entity is deleted, all owner weak entities must also be deleted. Weak entities cannot exist by themselves, and therefore this statement is true. Integrity constraints must be satisfied for all instances of the database. This also again is true. And this is based on a fact because when you issue an SQL statement that modifies data in the table, Oracle database ensures that the new database satisfies the integrity constraint. And also, all data in the table must conform to the corresponding rule if an integrity constraint is applied on a table. Our last question is, any serial execution of a set of transactions preserves the consistency of the database? This is also true, and it's based on the fact that serial schedule is one that does not interleave transactions. So it will completely carry out transactions, then move on from one to another. It won't stop halfway between transactions, and therefore it does preserve the consistency of the database. Thank you for listening.